moving on to lesson 3 in our ratios lesson. Again, we are under the tab M2-T1 ratios. We are in the lesson 1.3, determining equivalent ratios. It's got a clever little title. Oh, yes, I am the Muffin Man, the Muffin Man, the Muffin Man, if you know that song. For this page, if you're working on your textbook, you would be on this page, M2-37, where we're going to try to figure out equivalent or equal ratios. They act a lot like equivalent fractions, just to give you kind of a hint. We're going to skip this getting started, and we're going to get right into using drawings to model equivalent ratios. We're going to teach you a couple of different strategies, drawing drawings and tape diagrams and coming up with tables. And so we're going to give you some different strategies to come up with equivalent ratios. Let's get going. Carrie and her friends are going hiking. Carrie invites her friends to meet her at her house for a quick breakfast before they head out. She wants to order muffins. She knows there's a muffin combo that you can order, and it has 4 muffins that you can feed 4 people. Draw a model showing the relationship between the muffin combo and the number of people it will feed. So draw a picture. So I'd probably draw something similar to this. Here's my muffin container that has 4 muffins in it. And if I had 4 muffins and they can feed 4 people, I would say 4 muffins feeds 4 people. They're little stick people. I can write a ratio for this as well, and I can say 1 muffin combo feeds 4 people. 1 to 4, 1 to 4, or 1 to 4. All right. Next one, if Carrie invites 6 friends, how many muffin combos will she need? Draw a model, show how many muffin combos that she's going to have to order. Okay. For this particular one, 6 friends. So here's my 6 people. 1, 2, 3, 4, 5, 6. A few more people coming. If she buys her 1 muffin combo, that's only 4 muffins, not going to be enough. So she's going to have to buy her 2nd muffin combo to have enough for 6 people. She won't need to have all the muffins. She'll have a couple of leftovers, but she has to buy 2 combos because you can't go to a store and say, oh, can I just have 2 muffins and you keep the rest? So what this looks like would be 2 muffin combos to 6 people, or 2 to 6. Last one has a partial combo. Carrie must have got hungry. Carrie has 2 3/4 muffin combos. I'm not sure how you can have a muffin combo, 3/4 of one, unless you bought a pack and then maybe you ate one. Maybe that's what she did. So let's assume she has this. So she has 2 3/4 of one. So full ones have 4 muffins in them. She has 3/4 of it. She must only have 3 out of 4. So she must have eaten the other muffin. Okay, so she's got 2 3/4 muffin combos. How many friends can she feed? All right, well, we already know 1, 2, 3, 4 people per muffin combo. And then 3 people can eat this last one if she hasn't already eaten it. Okay, so the ratio would look probably like this: 2 3/4, 2, 4, 8, 9, 10, 11 people total. So 2 3/4 to 11. Great work. All right, now it gets a little trickier. It says, let's consider a different variety pack. So now in this variety pack that you purchase, there is 2 out of every 5 muffins are blueberry muffins. They got a little picture for you here. Blueberry muffins on the top. Total of 5 muffins. It says, draw a model to answer each question and explain your reasoning. Okay, so let's give this one a try. How many muffins are blueberry muffins if there are a total of 25 muffins? Well, in the variety pack, there's 5 muffins, right? And I have 25 muffins total. So I must have bought 1, 2, let's see, 5, 10, 15, 20, 25. Must have bought 5 packs, right? Now remember, 2 of them are blueberry. We'll say the 2 on the top are blueberry. And all I'm doing is redrawing the picture that's up at the top. But I have to draw it according to my problem, which says there's 25 muffins total. So 5, 10, 15, 20, 25. And it says how many blueberry muffins are there. Okay, well, if I add up just the blueberry muffins, 2, 4, 6, 8, 10. I would then have 10 blueberry muffins. Sounds pretty tasty right about now. Second question asks, how many muffins are blueberry if there's 35 muffins? So now instead of 25, there's 35. Rather than draw it all again, I'm going to cheat a little bit, and you steal this picture. So that's 25. Another 5 would be 30. Another 5 would be 35. So that's a total. Remember, I have blueberry, 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 blueberry. All right, so how many total are blueberry? Well, I had 10 up here, plus I've got 2, 4 more. So 10 plus 4 is 14 of them are blueberry. And last question, how many total muffins are there if 8 muffins are blueberry? Well, I think we can go back to this picture. If I only want a total of 8 blueberry muffins, 2, 4, 6, 8. So that's 8 blueberry muffins. How many packs is that? That would be 4 packs of muffins. But it doesn't ask for how many packs. It says how many total muffins. Well, there's 5 in each pack. So 4 times 5 is 20 total muffins. Great work. So that's how we can use pictures to help us come up with equal or equivalent ratios. Notice that in my original ratio up here of 2 to 5, 2 blueberry to 5 total, in this question A, I had 10 blueberry to 20 total, or sorry, not 20, 25 total. Remember, 5, 10, 15, 20, 25. And down here, I had 14 blueberry to 35 total. All of these are equivalent ratios, and that's what it says right down here. As you solve these problems, you determine equivalent ratios. Big words. And they're ratios that represent a part to part or a part to whole. Let's move on. Another way to represent equivalent ratios is by using something called a tape diagram. All right, so let's see what those guys are. In fact, actually, this first question is asking for some ratios, which I think you can do on your own. It says, the local bakery sells muffins in variety packs of blueberry, pumpkin, and bran. They always sell the muffins in the ratio of 3 blueberry, 2 pumpkin, and 1 bran. So 3 plus 2 plus 1, that's 6 muffin pack, basically. So go ahead and write the ratios for A, B, C, D, E, F for this first one on all the different ways they want, and tell if they are part to part or part to whole. Go ahead and pause this and then come back. Okay, hopefully you've got ratios for each one. Let's see what we came up with. First one says blueberry to total. Well, that would be a 3 to total was 6. So 3 to 6, or I could say 3 to 6, or I could say 3 to 6. I can write it any way I want. That would be a part to part or part to whole. I think that is a part to whole. Second one, pumpkin to total. Well, there's 2 pumpkins, and the total is 6. And pumpkin to total is a part to whole. Bran, there's 1 to total is 6. And again, that's a part to whole. Blueberry to pumpkin, 3 to 2. That would be a part to part, comparing two different types of muffins. And then we've got a bran to pumpkin, so 1 to 2. That's a part to part. And finally, a blueberry to bran, and that would also be a part to part. All right, so far so good. Down at the bottom, it says a ratio can be represented by drawing the objects themselves, but they could also be represented by using something called a tape diagram. Tape diagram illustrates the number relationships by using rectangles to represent ratio parts. Tape diagram representing the ratio of each type of muffin is shown below. So here's our original one, blueberry, pumpkin, bran, because the original one said they had 3 blueberry, 2 pumpkin, 1 bran, and if you add them all up, you get a grand total of 6. So yes, this works. What does each small rectangle represent in this? Well, in this particular problem, a rectangle represents a muffin. Great, moving right along. Tape diagrams provide a visual representation of ratios, but they also can be used to solve problems, like this one. All right, and it's saying over here, don't forget our original variety pack over here, 3 to 2 to 1. Suppose you purchase an 18-pack of muffins. How many blueberry, pumpkin, and bran will you purchase? Well, there are 6 muffins represented in the tape diagram, and you want a total of 18 that are the same ratio. Therefore, to determine how many muffins you need to maintain the same ratio, you could divide 18 by 6, because our original had 6, but you bought an 18-pack. Therefore, if you take 18 divided by 6, you get 3. So each rectangle down here is going to stand for 3 muffins. From the tape diagram, you can see that there are a total of 3, 6, 9 blueberry, 3, 6, 6 pumpkin, and 3 bran. Is this ratio, 9 to 6 to 3, the same as 3 to 2 to 1? Why, yes, I believe it is, because if I had 3 to 2 to 1, and I times them by 3, I would get 9 to 6 to 3. So yes, they are equivalent, and this is how equivalent ratios work. Well, let's try a couple more tape diagrams. Suppose you purchase a 36-pack of muffins. Use the tape diagram to illustrate how many would be blueberry, how many pumpkin, and how many bran. All right, so here's what do I know. I know this whole thing equals 36 muffins. Definitely know that. Okay? I know that each square has to have the same amount. The same. And I know they all add up to 36. So if I take 36, and there's 1, 2, 3, 4, 5, 6 total squares, I know that each square has to have 6 in it. 6, 6, 6, 6, 6, 6. Now I'm able to figure out how many blueberry, how many pumpkin, and how many bran. In this case, there would be 18 blueberry, 12 pumpkin, and 6 bran. And then again, is it equivalent? Think back to our original ratio, a 3 to 2 to 1. And this one's now 18 to 12 to 6. I think so, because each time I'm timesing by 6, times by 6, times by 6. Okay, go ahead and try the last one on your own if you can. Give it a shot. If it doesn't work out, no big deal. But pause right now and try this one on your own. Okay, so suppose you wanted 20 pumpkin muffins in the variety pack. How many total muffins would be in your variety pack? So 20 pumpkin, so 20. How many total muffins are there going to be? So So I don't know the total. And I don't know how many blueberry and bran. But if there's 20 pumpkin, and I do know that every square has to have the same amount in it, I know that if I add 10 and 10, I get 20. So each square must have 10, 10, 10, 10. That gives us a total of 30 blueberry, the 20 pumpkin, and 10 bran. If I add those up, 30 plus 20 plus 10, I get 60 total muffins, which is what they're asking for. Tape diagrams can be pretty helpful, or you maybe prefer the drawings. You'll have a variety of strategies and you'll get to pick which one you'll want to help solve problems. Okay, in this last one here, it's asking, now they give us a table. It says the table shows the number of muffins in specific size variety packs. So you can buy a 6-pack, a 12-pack, an 18, a 24, and 36. Complete just the missing cells for the 6 and the 36. Okay, well, we've already done the 6-pack one. That was our original thing, the 3 to 2 to 1. So we already know that. We already know there's 3 blueberry, 2 pumpkin, and 1 bran. All right, so it's asking, what would the 36 one be? Well, I can figure this out. I could draw a tape diagram, but I can also use my idea of multiplication to help me figure this out. So to find the 36 pack, what would I have to do to have total numbers of 6 to go up to 36? I would have to multiply by 6. And so if I multiply each one of these by 6, that should tell me how many muffins will be in the 36 pack. So 3 times 6 would be 18. And 2 times 6 would be 12. And 1 times 6 would be 6. Makes sense. I think I can use my multiplication to figure that out. I also noticed that they give me the 18 pack. And you get 9, 6, and 3, which I figured out on the other page. I'm also noticing that if I take 6 times 3, that gives me each of those numbers. 3 times 3 is 9, 2 times 3 is 6, 1 times 3 is 3. All right, so I'm making some observations. What do I notice about the numbers? I've just said them out loud. I can multiply to find missing values. Okay. B, how could you have determined the number of each type of muffins in the 18 pack without using the tape diagram? Well, we already kind of mentioned that. I said I noticed that it's timesing by 3. So I could have just used my idea of multiplying to come up with it. And then C, how could you have determined the number of each type of muffins in the 36 pack without using a tape diagram? So I guess in this one they did want us to use the tape diagram as before. So we kind of cheated and saw that we could multiply with it. But again, we saw that you could multiply by 6 to get 36. All right, we're going to pause here for a second. I want you to try D on your own. If you can draw a tape diagram, great. If you can use your idea of multiplication to figure it out, great. Just go ahead and try to fill in the numbers for the 12 pack and the 24 pack. All right, we are back, and hopefully you were able to come up with an idea. For the 12 pack, I know there's a shorter way, but I'm going to make my tape diagram. So remember that was a 3 to 2 to 1. And I know the grand total has to equal 12. And so each one of these squares has to be the same amount. And so that's a total of 6. So I'm going to divide them by 6. That means each square is going to be 2. So if each square is 2, I know that I would have a total of 6 blueberry, 4 pumpkin, and 2 bran. So I can put those right in there now. 6 blueberry, 4 pumpkin, and 2 bran. You may have also noticed that as a shortcut, I could have multiplied this by 2 to get the 6, the 4, and the 2. Tape diagram, picture, multiplying, all of them are great strategies. For the 24 pack, rather than make a tape diagram, which I most certainly could, I'm going to try to use this multiplication again. And now to go from 6 to 24, 6 times 4 is 24. So if I apply that, I would do 3 times 4 to get 12, 2 times 4 to get 8, and 1 times 4 to get 4. All right. I see quite a few patterns in that. I'm feeling pretty confident about tape diagrams and about making pictures to help solve problems. Great job here, 6th graders. We have one last section. Actually, we got a couple more sections on this particular lesson, but we're going to stop right there and pick up the second part of this lesson